All right, as we saw in the video when we're working with complex rationals, one of the things that we need to do is change it from its form that it's currently in into a division problem. And so as I'm looking at this next problem right here, there's the first fraction, there's the second fraction, and I want to rewrite that so that it's not as complex. So I'm going to start with the first fraction, so 40k minus 8, 50k minus 10, and then it's divided by this fraction 8/10. Or we can go ahead and go straight to the reciprocal, multiply the reciprocal of 8 over 10k, which is going to be 10k over 8. You can more than welcome to do that middle step where it's this first fraction divided by that second fraction. Okay. Then from here you just do your normal factoring, reducing, and combining. So as I look at this first one, I notice that there is a GCF, and I think I'm going to do it a little bit differently this time because I think I give myself enough room up here, but I notice there's a GCF of 8. So I'm going to write what's left over. 5k minus 1. And downstairs here, I notice that there's a GCF of 10. That leaves 5k minus 1. And over here I have a 10k and an 8. Okay. And now I'm going to hunt down the things that are common at the top and the bottom. So you should notice 5k minus 1, 5k minus 1, 8 and 8, 10 and 10, and that leaves just a k. And so that's our answer, is k. We do need to talk about the values that k cannot be. So that goes back to the original. So here's the original. I have to watch out what's happening in that denominator and then in that denominator. Okay. So down here, that's supposed to be an easy one, though I know some of us forget. That's just a 0. And then down on this one, I can use this 5k minus 1 part. I'll come down here. So 5k minus 1 cannot equal 0. That means 5k cannot equal 1, and k cannot equal 1/5. Okay. All right, here's the next one. Looks really scary, but it's not once you kind of start breaking it apart. First of all, we have this is our first fraction, so I'm just going to rewrite that. And we're going to divide the second fraction, but I think instead of writing divide the second fraction, I'm going to instead write multiply the reciprocal. So 10m plus 25 will come to the top, and the 6m squared plus 31m plus 40 will go down to the bottom. All right, so now I do my factoring. 3m plus a is a linear factor, or a linear binomial, but doesn't have a GCF, so I'm just going to wrap it in parentheses. 10m plus 25 does have a GCF of 5, so I'll take that out, and that leaves a 2m plus 5. This is just a regular quadratic down here on the bottom, so I'm going to assume that it's factorable. So I'm looking for the factors of 30 that subtract to be 7. Factors of 30 that subtract to be 7. And that's going to be a 10 and a 3. I want a positive 7, so it's going to be a positive 10 and a negative 3. Okay. Then this one right here, I would start with a GCF, hoping that I can take out a 6, but I can't. Then hoping I can do something else, maybe a 2 or 3, but 31 is making that a mess. So this is going to be our grouping method, Schaefer's method, if you will. So I'm going to come and do that over here. So what I'm wanting to do is separate the 31m into two pieces. To figure out how to get started, I need to multiply the first and the last, 6 and 40. That becomes 240. And now find all the factors of 240 that are going to add to be 31. And this can be kind of tricky. This may take us a little while. 1 and 240, 2 and 120, 3 and 80, 4 and 60, 5 and 12, 48, 6 and 40, 8 and 8 goes into 45 times 6, so that's 30. 9 doesn't work. 10 and 24. 12 and 12 goes in 24, 2 times, there's 20. And then we have 13, I don't think so. 14 doesn't feel like it. 15 does. 15 goes into 64 times 4, which is 16. So that is a tricky one. So maybe you missed that one. And that's why you need to go through all of them. My little multiplication trick does help with that. So both of them are going to be positive, so it doesn't really matter the order that I write these in. And then I'm going to go ahead and do my GCF, group them, and GCF them. And M, let's see, that's got a 3M. That leaves a 2M plus 5. This one has a 4 for sure. Looks like an 8, now that I think about it. 8. And that leaves a 2M plus 5. And then finally, our factoring, I'll just go straight up here to this step, is going to be 2M plus 5 and 3M plus 8. So it's very easy to get lost. You had a lot of side work you had to do. So remember what you were doing. We're trying to factor out that denominator. All right, so now you should start noticing some things cancel out. Let's see, I see a 3M plus 8, a 2M plus 5, and that's about it. So we are left with a 5 up here, and I see these two guys right there. So that's our final answer, which is 5 over M plus 10 times M minus 3. And I wouldn't spend the time foiling that out. It's no reason. This is a very acceptable answer here. I do need to find my excluded values. So it will be here and here and here and here, but also right there. Now if they repeat, I don't write them twice, but I do need to check up there on that second one. So these two are pretty straightforward. M can't be 3 and M can't be negative 10 because that's going to make those zeros. Then we have a couple of fractions here. If you set them equal to 0 and end up with negative 5 halves and negative 8 thirds. This problem down here is just another practice of using your grouping method. It takes a little while to get through it. I think I won't work on that one, but you can work on that one. And then we have on your own, where you can go back and check your skills, and then look at your syllabus for your homework. There is a Math Excel assignment, and there is book work that you need to be doing.